I'll give you a very practical example and I'll ask you a few questions. Suppose you've got a tap from which the water is coming out, right? And let's say you've got a hose connected to it, and to this hose you have another big hose connected, and water goes out of that hose. So water travels from the tap here, goes in here, goes out here. Right? Now let's say the capacity of this hose is 25 liters per minute. It's a small hose. And this bigger hose has 100 liters per minute. Tell me, how much should I expect here? How many liters should I expect here?
125.
I was going to say.
Done? 125? Try that at home if you've got it. You'll not get more than 25. The input is 25. How can you have 100 here? Input is just 25. No? So whatever is going in has to come out. Simple. Yes or no? Yep. Let's take another example. Same tap, let's say same pipe is connected to another house which has a bigger hose. 100 liter per minute, but then a 25 liter per minute, and that's going out. So it's not here. Let's say this is how they've connected basically. Let's say this is how they're connected. So let's say this is 100 going in, and you have another connection which is 20. How much do you expect will come out? Bill, how much?
25.
25. Right, Dana?
Mm-hmm.
Why? That's the only capacity to throw out. I cannot take more, right? It's as good as I have this much capacity of eating food. If you give me like a table full of meal, I can't eat all. I can only eat what's my capacity. Right? So what did we observe here? We observed that the maximum capacity of any network of connections is the minimum, is equal, the maximum output of a network is equal to the minimum capacity of that network, right or wrong? That's what we observed. Right? So the max capacity equals to the max output capacity equals to the minimum capacity of that network. Right? All good? Now, when you have a diagram which has weights in it and a direction as well, I call them as diagrams. Or directed graphs, right? So the question you'll be given, consider the digraph. So that means they're talking about a network diagram which has direction and it also has a weight in it. Right? All good so far? And you can extend that as well. So let's say, for example, you have another hose connected. Still, the output would be 25. So what we're trying to say here, Mitch, is that if you have a tap which is pushing water through this pipe, and this pipe is a small pipe and can only take a maximum of 25 liters a minute, and it's connected to another pipe which is a bigger capacity, 100 liters per minute, what will be the output? The output will be the minimum of the two, always. In here, same story. If you've got a bigger pipe attached to the source, throwing a lot of water, but then you've got a smaller pipe attached to it, and then another larger pipe attached to it, what's the final output? The minimum. So look at the minimum capacity, and that will be the maximum output from to the target, from source to the target. All good? In the world of flow and flow and matching, the source is called the source, obviously, and the target is called the sink. Source to sink. So sink basically means the target. Right? With me so far? Alright, let's do a question and that'll make more sense. So again, the maximum outflow or the maximum flow equals to the minimum capacity. That's the ground rule. Right? Let's do a question and try to implement that real life. Take this off the board.
Yeah.
All right. Let's say there are, that's how my diagram is. There are cities A, B, C, and E. That's how the traffic is flowing from between different cities. And that's the number of cars, the maximum number of cars that can flow from A to B, the capacity of AB basically, that pipe is 300, 600, and 800. If I now ask you, what is the maximum traffic flow from A to E? How many cars at the max can flow from A to E? Who can answer that?
1,700.
Sorry?
1,700.
Anyone else? These are the maximum capacity the road can, they can handle. You're talking about 1,700. That means they have to pass through this road. Can 1,700 pass through this road? No. Can 1,700 pass through this road? Can 1,700 pass through this road? No. Then?
800. 800.
Why 300?
Because the minimum.
Maximum output, maximum flow equals to the minimum capacity. Good job done. 300. You can't handle on this network, on this diagraph, you cannot handle more than 300 cars. More than 300 cars cannot go past at any given point in time. Make sense? Right? Okay, let's do another connection here. And there's another city D, which is connected to E. Right? And that's how the flow is. 500 and 150. Now tell me, what is the maximum that can flow from A to D to E? Maximum. Speak louder. Mitch, does that make sense? 150. Well, yes?
Yeah.
You know why, right? Maximum flow equals to the minimum capacity. 150. Cool. Good job. Now, if I now ask you, combine both of them. This was A to B, A to B to C to E. Now, if I ask you, look at this diagram and tell me how much at the max can flow from A to E. How much would that be? Any wild guesses?
Is the whole diagram. Or from A, B, C.
You're saying at all?
Wait, do you mean from A, B, C, E?
See, the traffic is flowing in all directions, both the directions from A, and they are reaching E. What's the maximum that can pass through E, starting from A?
150. 150?
The reason why you said 150 was that you applied the logic of maximum capacity equals to the minimum. The maximum outflow or flow is minimum capacity, correct? That would have been the obvious answer, but unfortunately that's not the right answer. Now, all of that comes with a pinch of salt and some more logic. If I look here, at E, what is the max? If I just forget it, what is the max E can handle? Max? 800, right? 800. That's the max in general. Anything past 800 combined, it can't handle more than 800 all combined. This flow is throwing 300. This flow is pushing 150. What's the maximum E can handle? Only E, 800, right? So that means, and if I combine all of that, this is 450, still less than 800. So that means the maximum capacity that can flow from A to E is the combine of the two minimums. Does that make sense?
So it's 450?
450, yeah. Why 450 is the question again. Because this road is throwing 800. This road has the capacity to throw 800 cars at E at the end of the day. So if 300 come from this direction and 150 comes from this direction, would E be able to handle? Yes. 450. So 450 at the max is the flow between A to E across the board. Make sense? Yep. So you cannot blindly say, all right, look at the minimum and probably just write that number there. No. You need to check where is the final output, what's its capacity, etc., etc. Let's make this problem a bit more complicated. Let's say there's a new road that has been constructed from C to D. And this road allows you another 500 in this direction. Now, can you tell me what would be the combined capacity of flow from A to E? What's the overall max that can come out of here? Tell me. Come on, give me some wild guesses. No, that's okay. You're learning for the first time, you can fumble. There's no harm saying incorrect. No one's judging here. Yep, well, throw me a number.
150.
150. Alright. Done. Throw me a number. If you have to do it. Let's say that was the only mark, that was the only question in the VCE exam, 50 marks. One question. You'll say, I don't know. You'll come out of it.
300.
Mitch? 300? Alright, let's try that. Let's try various paths and check. A, B, C, E. The minimum flow was 300, correct? A, D, E. I'm trying to see from which all directions can traffic reach E. A, D, E was 150, correct? Now we have a new path. A, D, C, E. What's the minimum? In this new path, what is the minimum? 500. So I have another 500, which is A, D, C, E. Did you remember last time what we did in the last question? We added their capacities and I said that's the minimum, that's the max that can flow out. Let's try that here as well. So I say 500 plus 150 plus 300. How much is that? I will look at what is the maximum capacity at E only. How many cars at the max E can handle as an output? 300. So that means if 950 are approaching E, 800 can pass at the max. Let's say this would have been 1,000. Then I would have taken 950 because it would have handled the pressure of 950. Do you get my point now? What I've just done, right? So this is playing all the game, controlling all the game of the output. Does that make sense? Why I have not taken 950 and I've taken 800? Yep. All good. Now if this would have been 700, then I would have a 700 here. A 600, I would have a 600 here. So on and so forth. Right? All good with me? Let's now do a bit more confusing thing called the cuts. All right, let's do the cuts. Shall I take this off the board? Now, see, this way of solving is challenging. It can be handled to a point where the diagrams are less, sort of complicated. If I add more roads here, then that will become a challenge doing all of that, right? Trying to find different paths and then calculating and then adding and looking at the end, blah, blah, blah. So there's a better way of doing called applying the cuts. And what is a cut?